be rather more casual. I am actually thinking about talking a little bit about the questions that Zeno was asking earlier as a start here, simply because, nice transition from before. So I don't have any new slides here because I turned out to not actually be that fast about creating slides over lunch, but that's okay. We'll use this as an explanation for where to find information. So, for starters, what I've got up here is the Trusted Computing Group's website. Shiny and new and still not very well organized, which is way better than it was 6 months ago, be glad. So, if you're looking for information here, in general, the place that most of the information you want is in the Developers tab. And here, there's options for all of their crazy little working groups. And unfortunately, this is where the fact that you need to know a little bit about how the TCG thinks matters. Because the TPM specifications are intuitively under the Trusted Platform Module tab, whereas the spec for real-world TPMs, for TPMs that are actually in your machine, where they say which commands are required, what the minimum threshold for number of PCRs is, what those PCR constraints are, well, that's actually technically the PC client specification for TPMs, which lives up in the PC client working group. Sorry. So in general, and you can just browse around these. There's a whole bunch of information here. Not everything that has a tab has very much out yet, but we do have all of the TPM module specifications on the website here, including some things that are not quite specifications. Best practices doesn't actually tell you all that much. But the TPM main specification is where most of the information we're going to look at is. And that actually breaks down into 3 parts. The website's being slow. The design principles, the structures, and the commands. So we had a question earlier about NVRAM. So what we can do here is, in general, when I'm looking for information about how do I do something with the TPM, the first place that I start is commands. Design principles has a whole lot of background information. It's what it sounds like. It's the high-level description. What is NVRAM? What's it for? What are PCRs? What are they for? Sometimes that information is critical. It turns out that the fact that you check PCRs on key use for every single operation, it's actually buried in the design principles, because it's a universal operation. Why should we include that as a step in the commands? But for the most part, commands are where you start if you want to say, what can I do? How can I do it? So the one thing that TCG is actually pretty good at is that they pretty much all have fairly solid tables of contents. And you do need to know enough about a TPM to make sense of where to look. For example, if you don't have any idea that the TPM refers to its flags as capabilities, the fact that the get capability command really doesn't mean much. I don't know why they call those capabilities, but they do. In general, if you run into something that, woo, I'm back. Awesome. Awesome, thank you. If you run into something that you're not familiar with, this is also a good place to get a sense of what's going on, because as you'll see when we get to the commands, most commands do have a couple paragraphs of description at the top of them which tell you what they're for, and most of these sections, like the audit section, actually have a description at the top of the section saying what these commands are, how they relate to each other. So if we want to look up the NVRAM commands, we're going to scroll down to the section on non-volatile storage. So if you show up, you look at the command, you search for NVRAM, and you don't find anything, unfortunately, the TCG uses a lot of different words to refer to the same concepts on a regular basis. So if you don't find something when you search with the first phrase, check the table of contents for anything similar. and then look around for other things you might be able to search for that might be a little more informative. So here, does this actually work? Yes, awesome, cool. As you can see, not all of the informative comments are actually very informative. It handles non-volatile storage. Yes, the title tells you that. So, in general, when it comes to non-volatile storage, we've got one command that establishes space. It's basically memory allocation. And I'll be honest at this point. I have never actually used NVRAM. I've read about it, so I'm not going to tell you too many details about when to use it or how to tell when it's working or not, because I have no idea if there's any traps lurking here. Each TPM command has, and I sort of wish that I could gesture at your screen here, a list of incoming operands and a set of outgoing operands. Some of these are repeated. If you look here, you'll see at the top there's a tag and param size and an ordinal. Every command has that. The tag is basically, this is a TPM command that's incoming. I don't think I've seen very many that have a different command, but I don't look at things like the power on commands very. Power on is not technically a command. It's a thing that happens on just when the power turns on. That one probably has a different tag.
Ariel, can you zoom in a little bit? Like, just increase in Adobe?
Let's see.
Thanks.
Okay. This will cut off a little bit on the size, but it'll be easier to read. If anything turns out to be relevant on the size, we'll switch things. So at the top you can see that there's a tag and the parameter size, which is pretty intuitive. The parameter size is the size of the data structure you're sending to the TPM. The ordinal, every TPM command has an ordinal which is just, you can think of it as the command name. At that point, there are then a set of arguments for each command. And then there's this double line in the middle that you can kind of barely see that's a little bit thicker that comes between enc off and off handle. Every TPM command will have that double line. What's beneath that, you can see this is authorization session handles, nonces generated by the TPMs. These are part of the TPM's basically communications protocol with the driver. For the most part, when you're trying to figure out what a command does, those last 5 don't matter. Every TPM command has something that looks pretty much identical there, that is really there for ordering commands, making sure if you have an authorization session running, we know which authorization session you're using. That you can think of as overhead, pure overhead. If you are implementing a TPM driver, or something at the level of a driver, you care about those. But if you're not, if you're just trying to figure out, what do I do, what information does the TPM need, and make sense of things, what you really care about is whatever is between the ordinal and that double line. So here, what we're looking at is a set of public parameters of the area, which is, I wonder what that means. We have an NV data public. We'll get to how we answer that question in a moment. And then we have an encrypted authorization data, which if that NV data public is configured in some fashion, we may require authorization. In this case, I suspect there's an authorization required in order to define a set of NVRAM space. Outgoing parameters, again, these are going to be very common. Every TPM command will have a response code that includes the ordinal and the tag and the size of the parameters that are being returned. They also all have a return code. There's a TPM result data type that basically has, this is if you've ever programmed for really anything that interacts with an operating system, the operating system will throw back success or error, and if it's an error, there will generally be types of errors. This TPM does the same thing. There's a list of return codes that cover everything from miscellaneous failure, which is the most obnoxious error code in the world, to authorization failure, TPM disabled, no owner, EK already exists. So most commands will tell you which errors they return. This is not always comprehensive. I have been known to get error codes that are not officially returned by that command in question, and I still couldn't tell you why. But, for the most part, the list of errors you expect to see will be defined, and if the command succeeded, one of the results is success. So this one, you will note, does not return anything interesting. It basically says, yes, you succeeded in defining the space, no, you didn't. There will then, and in fact, here again, and unfortunately it's broken into 2 pages, so it's a little harder to see. Under the ordinal, there's a slightly thicker line. Then there's this thing that says nonce even, nonce odd, continue off session, and under off. These are all, again, part of that session management. I will note here that here, some of these are interesting if you care about how do you implement this, how do you do authorization. For example, here that this says the continue use flag is fixed to false. You cannot run this command and then continue using the same authorization session. If that were set to true, then you potentially could continue using the same authorization session. Some commands that are designed to be used in series will actually have this either default set to true or you may set it to true. That said, I pretty much always ignore those final 4 blocks because these are pretty much constant for commands. Unless you are trying to implement an authorization session, this is irrelevant to you. This is not going to tell you what data you get back. This is about the interactions with the TPM itself. So here, and unfortunately this is, let's see if I can, it's a little bit bigger. Oh, that's interesting. You can see this better on the computer than on the screen. Here, we have a description of what this does, usually. This doesn't always exist. And then we have a sequence of actions that the TPM takes internally to determine what the result of the command is. And this is often pretty darn cryptic. Here, we are referring to, within that set of information we've passed it, if the index has a particular value and the tag has a command, then we'll do some extra logic. This is where we start getting into, in order to make sense of that, we're probably going to need to jump across to the structures. And just like we were saying before, there's this NV read data structure. If it's a data type, or if we're starting to talk about, if it's got an arrow, that's a pointer, so a subset of the structure has this particular value. Or if we just want to make sense of a whole bunch of capitalized tags like that, that means that we're going to jump over to the structures spec and search for whatever we're looking for. Because this doesn't make much sense if you don't know what the data structure you passed in is and what these are for. But that said, we then start to look for, well, here, if the non-volatile RAM is false, we ignore all of our authorization checks, and then that specifies what that means. And here we're taking some action based on what we're doing. So if this is actually an authorized command, validate the command because it's authorized, and then proceed. This one is really, okay, so this one, this is a terrible example of how to read commands because this is a pain in the neck. This one, first, if you're using an authorized command, then you need to check that the owner authorization is correct. Otherwise, you can run this command if you have physical presence. So this is basically what this says, is this is designed because the manufacturer may put things into NVRAM during the creation of the TPM. Mm-hmm. There is no owner at that point, so they can't provide you with owner auth. So the NVRAM commands all provide the option for someone with physical access to the TPM to, before the owner is set, use physical presence to put things into NVRAM. And there is actually a hard limit on how many times this can be done. This is a flag. I went and read it during the break. So here you can see, if we have physical presence, first check to make sure that we actually do have physical presence. We're not just claiming we do. And by the way, if there's a TPM owner, say, you can't do that, there's an owner that is not allowed. Return TPM owner.
Do you happen to know how it checks physical
and then we
presence?
Start. There's a physical presence flag that is set when the TPM boots based on certain criteria. The criteria depend on the platform. In some platforms, physical presence is set basically by the BIOS. There are others where it's set because you were pressing a particular button. It depends on the platform.
So it's probably something where like the BIOS could set it and then it'll unset it once it knows BIOS is done, and we're going to let the thing continue to the rest of the operating system.
Yes, you are not required to unset physical presence when you proceed to the rest of the operating system. You can unset physical presence with a command. You cannot set physical presence with a direct command, I don't think. But in some cases, the goal is, in fact, if you want to do a bunch of commands that have physical presence, you don't actually want the BIOS to cancel physical presence for you because you're not running your own code in the BIOS. So depends on the BIOS, depends on the platform. That's not an area where we have a lot of data as to what most BIOSes do. It's a flag, you can look it up. This is actually a pretty straightforward thing to test, but we don't have the data yet.
Yeah, so I've been writing down basically a list of various experiments which need to be done, and that's something which we can actually check for in our work.
Mm-hmm. Yep. So here, you need to make sure you've got a legitimate data size. You've got non-volatile. You've got this has a whole bunch of checks. Checks are not very interesting. The problem is most of these commands have a lot of checks, and this one has more than most. Checking to make sure that we haven't maxed out our number of non-volatile RAM writes without an owner. We're checking to make sure that we are not already using a valid storage area, or if so, that we're doing the right thing. We're allocating some space. This takes a while. Here you can see what sorts of things the TPM does when it's doing sanity checks. So here, it's checking to make sure that various flags line up with each other. I'm a little surprised that there's an authorization conflict if we say the owner should be able to write to this NVRAM and you can write using an authorization flag, a separate authorization password. But apparently you can't do both of those. I'm not sure I would have guessed that without looking at this error. Similarly, we can't use both the owner reader and authorization read. All of these flags are going to be defined in that initial structure that I said we would have to look at. So let me go take a look at that structure, and you can see when we're trying to figure out how the TPM works, we really are going back and forth between structures, between documents all the time. And here we're writing to a defined area, which may or may not be authorized, may have attribute protections. Have some comments here that don't make much sense in isolation. I wonder why, what B global lock means and why it is intentionally set to true before the action checking the owner authorization. I don't know what that means. If we want to make sense of that, if we want to care about what that flag means when it changes, we're going to probably want to be going back to structures and figuring out what that lock flag does. But we're not going to worry about that right now. But you can see here what its purpose is. It's saying the BIOS can lock the NVRAM without knowing the owner authorization. Okay, sure. That probably means that setting a lock to true is something that you do defensively to make sure nobody's messing with NVRAM. We'd like the BIOS to do that. That's a good thing. And here, we can see again this very similar structure where we got that tag and the parameter of the ordinal. And here we are taking just the index. You'll remember last time we had that complicated data structure with an index as one of the fields. Here we don't need that complicated data structure. We just pass in the index. And an offset so that you don't have to write to, if we've got 100 bytes of data, we don't have to always write to 0. We can say we're writing to this area, but we're writing 20 bytes in. And then, of course, we've got some set of data that we're writing in where we have a data size and data. It's unsurprisingly very common here to have a uint32, how big is the data I'm passing to the TVM, and a byte. Byte here, the TVM uses bytes all over the place. This is really an int, an unsigned int, but it's 8 bits of data. That just byte array that contains however much data that we're going to be putting in. And here again, there's these 5 values that should look suspiciously familiar, which have to do with that authorization session. And here again, we have a return code that's just a return code, and we're not returning any actual data. And again, we have 4 authorization fields. Here you will note that we have the choice of, in some cases, this will be set, the continue authorization session will be set to true. I'll be perfectly honest, I have never done enough with authorization sessions to tell you the exact logic of why some commands say true, some commands say false. There are whole long sections of the specs about authorization commands. There's 3 different kinds of authorization session. It's complicated. We are not covering that today, in part because I couldn't tell you very much about it, merely that they exist. And here, again, we've got that we ignore checks, which checks we ignore. Remember I said NV locked was the flag we care about? This is why. And here, we check a bunch of permissions. And depending on what the permissions are, we may return a whole bunch of errors. This is pretty standard TVM activity. And eventually, we may, in fact, get to the point of writing something once we've followed through on every possible error that we could return. Remember how I said the return codes do tell you something about the errors? Here, you will see we have errors like this area is locked. We have the wrong PCR values. We have the wrong locality. So it does actually provide you with some information about what you're doing wrong. It's just not always very detailed. Here area locked, here bad locality. Bad presence, if you're trying to say, I can write to NVRAM because I have physical presence, and there is no physical presence, you get an error. You don't actually have physical presence, but you're claiming that you do. Setting a data size to 0 is apparently equivalent to I'm changing the value of certain flags. That's one of those things that you really do need to, this is why you skim through these commands. Every so often you discover that there are special inputs that do special things that are not always intuitive. It's probably documented somewhere. It was probably in that informative comment if you knew what you were looking for. And otherwise, we start saying, well, if there's enough space for the data, if there's not enough space for the data, don't write it. But otherwise, the bulk of this command is a whole bunch of error checking in this one line. Write the new value into the NV storage area. Congratulations. This is generally what reading the TPM spec is like, a bit of a pain in the neck. We have different commands for writing a value and writing a value with authorization. Note that this is authorization other than the owner authorization. I'll bet the fact that these are two different commands is why when we looked at defining the space, it said you can't have both owner authorization required and other authorization required. That makes a certain amount of sense. You can't use two commands simultaneously. I'm not going to go into this in any detail. This looks suspiciously similar. But here, of course, you do need to make sure you've got the right authorization session going on. And there are similar commands for reading values as to writing values. And again, there's a different command for reading with and without special authorization. So, let's see, is there anything else I can do with NVRAM? Let's see. Yep. So that's NVRAM in a very complicated nutshell, along with a little bit of a guided tour of what TPM spec reading is like. People have been very silent here, and I can't really blame you. Do you have any questions? Is this useful? Do you want to go into any of this in any more detail? Shall we move on to other things?
That was useful for me just because, I mean, I've skimmed through it before and I didn't realize that the data structures were in the other document and that they would be required to get a full picture of things.
Yes. There are really 4 specifications that you're going to need to have on hand if you're going to be serious about using the TPM. 2 of them you will refer to all the time, which are commands and structures, because commands don't make any sense without structures in hand. The others, and I will give you, let's see if I have them here and you can get a basic sense here. The design principles contains all of the informative commentary. So if you want to figure out the why of anything, if you want to find explanations for what the TPM is thinking when they do something, what the committee was thinking when they designed something, if it exists at all, it's probably in design principles. It doesn't always exist at all. I'm sorry to disappoint you there. Designed by committee is really the definition of the TPM, and committees do what they do. So the design principles is also where you can find any information about the TPM itself, not what it does, but what it has in it. Things like the components of the TPM. That little diagram I gave you is based on a simplified version of what's in the design principles. Here it talks a little bit, I want to know what are the requirements on non-volatile memory. As a component, that's going to be in design principles, or it's going to be in the next spec I'm talking about. And here it talks a little bit about processes, what matters about endorsement key creation. So the command spec will tell you what does the create endorsement key operation do. The structures spec will tell you about the arguments and the data structures you pass in, but if you want to know what the requirements are on what information is and isn't allowed to leak and when commands are allowed to be run, you will get the most information looking at the design principles spec. And if you're really trying to do something like understand what's going on with, here's where I looked up the dictionary attack information for you, Zeno, is security. This is about security requirements. It's not about a specific command. That tends to go into design considerations. So if you're trying to get a handle on a new area of what a TPM does, this is often a pretty good place to start. If you're thinking about protocols and usage, this is a pretty good place to start. It often doesn't have as much information as you'd like. If I were going to try and make sense of authorization commands, you can see there's a whole lot of information here. I skimmed it once, which is why I don't think I understand authorization at all. I don't think I'm going to look in here in too much detail for what it has to say about non-volatile storage, but you can see here there are design principles for non-volatile storage, how it's intended to be used during manufacturing, and if you were going through and trying to read those non-volatile RAM commands in isolation, and you're saying, why the heck do I allow writing to NVRAM without any kind of owner of? What does all of this global lock stuff mean? Why am I incrementing a counter every time I write when I write with physical presence? Why is usually when you start going back to the design principles to say, what the heck is going on? And here, that section will tell you that the use of NV storage during manufacturing is because we want the manufacturer to be able to write certificates without worrying about creating an owner or having that cleared. This is also where it will talk about things like, you remember when I talked about clear, I said it will clear all of the non-manufacturer sections of NVRAM. The information about what the manufacturer sections are meant to be will probably be in here somewhere. So that is the design principles spec.
So before you go on,
the other
there's
specification,
data integrity register that I saw in there. Do you happen to know what that is offhand?
Not the slightest clue. We can look it up.
Let's go back and click on that. It was towards the beginning.
Looks like it's deprecated.
Alrighty.
Which is why I was not familiar with it. So, looks to me like, remember how I said that the main purpose of NV storage is I can put a hash or something in NV storage that I can then later on read back to make sure I've got data integrity? I've never read the 1.1 TPM spec, but based on this description, my bet is they gave you specific registers for that purpose, and this time around they said, why are we requiring that they be 160 bits? Why don't we just give you memory that you can use for whatever similar purpose you want? It's more flexible. That has generally been the trend of TPM specifications, is that we go from very specific constraints to more flexible security at the cost of more complexity. The 2.0 specification does not have 3 parts, it has 4 parts. The 4th part is code. They had too many problems with different people interpreting TPM commands differently, so the actual specification, the normative portion of the specification, is in C. And all of the functions that do anything are in the 4th part of the specification. If you thought reading this was bad, wait till you see that. So if I want to go beyond what does this command do to what is likely to exist in my TPM, what commands is my TPM going to have, what are the minimum values that my TPM will implement, this is where we get to the PC client TPM specification, because this tells you the minimums that the manufacturers must meet. Some amount of what the manufacturers may not do. There is some of that in the design principles also. For example, one of the things that is required for meeting the TPM specification is that there are some things you may add extras of, like PCR values. There are some things you may not add extras of, like commands that access TPM secret data. We're very glad that they banned that from the TPM. This may actually be a worthwhile time to mention that over lunch, while Lisa asked some questions, we did go and look at the conformance section of the TCG's website, at which point we discovered that the TCG has a conformance test suite for TPMs, but does not execute it itself. It basically hands it off to manufacturers, and the manufacturer can say, yes, we certify that we have run the conformance spec and we meet it. Exactly one TPM manufacturer has done this. It is Infineon. That was depressing. So, the PC client spec is where I pulled things like that locality table from, where I pulled that list of how many PCRs there are. You can see here, this tends to be things like size, number of PCRs. Ordinal table is which commands the TPM is obliged to support. So the PC client spec is one of those things that you look at less when you are implementing, and more when you are trying to figure out whether something is likely to exist, or when you are trying to make sense of a strange error or something not existing that you think would. You go back and you say, is this actually required? Is this a bug or not? So here you can see we have a list of mandatory and optional commands. Some of these that say deleted in TPM 1.2. The 1.2 spec includes a whole bunch of 1.1 commands that are listed as deprecated. The PC client spec has apparently said, we are removing these because it is not only deprecated, you really shouldn't use it. We're not even going to allow you to include it. So here you can see that most of it, all of the certified migratable key things are required. Maintenance archives are not, but we do have things that are suites. So if you implement one, you must implement all. That makes a certain amount of sense. If you allow a revocable endorsement key to be created, you must also allow it to actually be revoked. That makes sense. So for the most part, this is useful if you're just trying to figure out whether or not something will be in your TPM or not. And yeah, some of these are a little depressing. You cannot actually tell the TPM to sign its flags, so you can test to that. That was a deprecated command. There you go. So that is the fourth spec that you are likely to want in special cases. You can largely get away for day-to-day use, or if you're programming, with just the main specs. So that is our little spec tour. So in terms of where I got these, I got those off the TCG's website. The PC client spec, again, developers PC client. If you want to experiment with new and different sections of the TCG's specifications, if you want to find out what does a mobile trusted module actually do, the mobile trusted module spec is also here over in the mobile section. Zeno, can you delete random sentences that I say in the video?
Yep.
Okay. So MITRE is actually a member of the TCG. We are a consulting member, so we don't actually pay the TCG any money for this privilege. We also don't get to vote on any kind of specifications. But what this means is two things. One is, if you have a strong opinion about how the next generation of anything ought to be implemented, and you can convince a sponsor to pay for your time, or you actually want to volunteer, you can basically submit a resume to the TCG with a list of the committees you would like to be on. And in general, as long as the head of the committee is okay with it, you can join that work group. There's a members login, at which point you can start seeing the behind-the-scenes stuff, the specs that are work in progress, the arguments between various people on various committees about what should and shouldn't be done. Most work groups have the general opinion that, wait, you want to join our committee and help us do our work? Okay, and we'll let you in as long as you don't seem like a complete nut job. This is why I do have access to things like the 2.0 specification. Now, the 2.0 specification is, I believe, currently out for public review. It's certainly out for some kind of review right now. The virtualization working group is planning on putting its spec out for public review in probably late June, early July. So if you want to see specs in progress, you can either wait for the public review period and send them feedback, but it's not like they have any kind of please sign up to notify me when this happens resource. That would be too easy. Much more likely is if you do have a reason to get involved, sign up, get a member login, join some work groups. You're not under any obligation to go to all of their meetings. I'm on a couple of work groups that I've never been to a single meeting for because, we weren't sure. And if you don't want to go through all that hassle, but you do want to find out specific details like what's in 2.0, what's in the virtualization spec, you can ask me or somebody else who's already involved in the TCG. There are NDAs that, of course, all of this is subject to, but this is a very useful resource if you want to get behind the scenes and start looking at not just what do we do now, but what can we do in a year or two. Okay.
So I've got one sort of question comment. This is pertaining to the whole, if you've got opinions thing. Do you think it would be reasonable to make it part of the spec that TPM manufacturers must actually publish how you send commands to their TPM? Because it seems to me that obviously one of the big problems with TPM stuff right now is the in lack of software that people can just generally use in order to send the commands they want. And like you said, the higher level abstraction layer has been done on Linux with things like Trousers, but you need it for Windows. You've got Windows built-in things just requiring commands, and you don't have published commands. So do you think that's reasonable that that is something that could actually be included with the spec, like a list of what the command blobs are that map to a given command? Like, could that be required of manufacturers?
I doubt it, for a couple of reasons. One of which is that the TPM manufacturers generally want to turn around and say this is the platform manufacturer's responsibility for anything beyond actually creating the chip. These folks are generally specialized hardware manufacturers. These are cheap chips. They're going to push back hard on anything that is a requirement that they don't feel ought to be part of their responsibility. Their response is probably going to be something like, this is Microsoft's job. Because to be perfectly honest, Microsoft provides a mechanism to send commands to the TPM. It's buggy, it's not reliable, but it exists, and therefore I would expect the TPM manufacturers to come back and say, that's not our problem,
No, but
that's the OS problem.
The commands are still their problem. I mean, Microsoft can provide a way to send commands to TPMs, but they still are, whether it's Microsoft or Dell or anyone else, they still have to go to the manufacturers and get the actual specs of how they send commands to what the command format is for any given TPM. And so that seems like the data is already there, and it's just not being published. Is that not accurate?
I don't think so. So the TPM spec, all of that stuff that I was describing there with the commands, that is the structure of commands that go to the TPM.
Okay, so that is the actual raw data of the, just put together your blob like this with these size fields, and that is the actual structure?
Exactly. So you can see here, and this says number, this is numbers, this is basically the ordering, I think. And this is the size in bytes. I'll be honest, I don't actually remember exactly what this HMAC section does. I've only programmed at this level a couple of times. It was a bit of a pain in the neck, but it can be done. But this is the command spec. This is exactly what the TPM must accept in terms of data blobs and formats. And if you look at the command spec, here we do in fact just have the TPM NV index here with the size, but the structure spec also, every single structure, if you can find one that drills down, this has a data type, this is UINT32, this is a Boolean, those are defined somewhere. I think also in this spec, but there's a chance that that's in the library somewhere. I think that's in the spec. Searching for bool, unfortunately, is going to make me a very sad camper. But these do, in fact, say, these are data types. I've just lost what I was looking at. Here, any flag that is defined has a value. For the data storages, we do have, this is a 32-bit value. Here's what these mean. So the structure spec and the command spec put together should tell you everything you need to know. Should. Not always comprehensively, but it's there for what the TPM will accept in terms of command format and command structure.
Okay, then I probably just was misinterpreting something Corey was telling me. I'll get clarification on that and get back to you if I'm wrong.
Yeah, sounds good. The impression that I'm getting, that I've gotten from when I last talked to Corey, is that the problem is not the TPM spec doesn't contain the relevant data. It's that the Microsoft supposedly pass-through software that says we will take a TPM data blob and send it to the TPM and come back with a TPM response blob, modifies the blobs
Yeah, I'd got that from you
in some
too.
unspecified fashion.
There's definitely an outstanding bug.
Are there any other questions about using the spec, or would anyone else like a guided tour of how something else works? I'm not sure how much we want to go through things like delegation here, although I can give you, the 10,000-foot summary here of what delegation.
I would still like to see at least, if you, even if there's not any specific table having it, just if you can cover, examples of things that can be delegated, that'd be good.
Sorry, I'm having more trouble than I should operating something as simple as Adobe. There you go. So this is the point that I say delegation is one of those things that I've looked at. It was a while ago. I don't even entirely remember exactly where the delegation tables are stored, but there are several different delegation commands. I'm hitting the delegation row. Family tables. I wonder what a family table is. You'd think that would be a nice and easy thing to discover, but let's find out. TPM family flags. Okay. Operational state of the delegation family table. These are in addition to the TPM permanent flags. Okay, there's a label. We don't care about labels. An entry row in the table. That does not in itself look very interesting. Okay, so family tables appear to be pretty non-helpful as a structure. And this is the problem, is that for some structures, the structure, or for some commands, the structure is where all the meat is. For other commands, the structures are completely non-helpful, and the command is where all the meat is. And unfortunately, that is not actually predictable. But here you can start to see that this is a delegate role that is public with no sensitive information in it. We've got some kind of label. We've got a set of PCR information. We've got a TPM delegation's permissions, a family ID, and a family verification. And
so can we see that TPM
here
delegation structure? I think that probably is going to have
get to in a second. I suspect so. I just wanted to see if there was anything particularly interesting in the summaries. Delegate sensitive, delegating an owner blob, a key blob. Delegations in a 64-bit field, describing a capability that can be delegated by setting that bit. That's interesting. Okay. So, in general, actually this is kind of cool. According to this, for the TPM commands listed in the following table, if the bit is set to 0, then that process has not been delegated. If it's set to 1, then it has. And if it's not listed in the table, it can't be delegated. You can only delegate at the level of command. So where is this below table? Here we go. So here, the permissions that can be delegated, which I believe was a question somebody had, we can delegate whether or not you can set, so key control owner, that's the relevant command for doing owner evict. Whether or not you can audit, migratable keys, writing to NVRAM, using direct anonymous attestation. Maintenance archives, which is one of those features that I don't believe actually normally exists in PC client TPMs. Making identities, activating identities, So there's a whole bunch of stuff in here that people may want to be able to delegate. Capabilities. I love that. This section is going to remove any ambiguity about the order of bits. Lovely. And this is handily justification for why you cannot delegate them. I happen to very much enjoy TPM take ownership. If you can't have an owner, how can the current owner delegate the command? Yes, thank you. Here, this is very similar. Key permissions that can be delegated. Let's see. You are now seeing why answering questions about TPM structures often takes a little while, because did we just loop? Oh, we're crying out loud. Oh, TPM delegations is in fact the name of those two blocks of permissions that we just skimmed down in terms of which ordinals are allowed. So that is a delegation. Does that answer your question in a very confusing fashion?
Yep, that's good enough for now.
Yep. So this complexity is part of why I didn't talk about things like NVRAM and delegation, not because it's not possible to distill it, but because this is stuff I don't work with very often. So I didn't have on hand enough of a complete picture to be able to put together a quick summary very easily. The main reason that I can talk about the many things that I do fairly straightforwardly is not so much that they're not complicated as that I use them. So welcome to the TPM. It is very, very confusing. But it is worth noting that we can both delegate for owners, we can delegate for keys. What that's supposed to mean. Privilege to use a key rather than, okay, privilege to use a key. That's pretty cool. So apparently, if I've got a key that has permissions on it, I can delegate some operations with that key using the delegation commands. That's kind of neat. That implies that I can say, if I've got an identity key and I want to constrain its use, I can say, you are welcome to use this identity key for giving out a quote, but I'm only going to allow you to use it for giving out a quote. I'm not going to allow you to certify other keys because maybe I want to reserve that permission for myself. So that's a bit of flexibility I hadn't realized the TPM had. That's kind of neat. I doubt it comes up very often, but it's kind of neat. Any other questions in our little tour? The other thing that I will just highlight here very briefly is this is TPM key control owner is the command that allows the owner of each bit flag to be set. Did I cover this already? I've gone through so many things today I can't remember what I said and what I haven't. I didn't have slides. So owner of bit is a bit that says the key remains in the TPM's key storage until it is explicitly removed. And in order to be explicitly removed, you have to unset the owner of bit flag. Key control owner is the command that sets and unsets that bit. That's all this command does. And the things to note about it are, first, that you must both explicitly set the flag and explicitly unset the flag. The key that you want to make owner evict has to be in the TPM at the time. That's pretty reasonable. Also, one of the things we haven't really talked about is that the TPM does track parents in one way. We've said that TPM keys can be PCR constrained. What happens if I have a storage key that is PCR constrained to constraints X, and I use it to load some other key Y? Well, now, later on, my PCRs may change. Y is a loaded key, but in order for Y to be loaded, X had to be true. So this is set in the TPM with something called basically parent PCR status. If a parent key, any parent key as far back as you like in the hierarchy, even if you're 10 keys down, if any key has that parent PCR flag set. All keys that it is the parent of will also have that set. Because there are certain scenarios where we want to say things like, we have unlocked this key because we entered a good state. Now everything after that requires that good state as a prerequisite. Or we wish to do things in a specific order. It would be a very bad thing if we had a constraint like that and then we set one of those late keys to owner evict. Because after all, now we can reboot the machine and those prerequisites no longer hold. So the owner evict bit can only be set for keys where that parent PCR status flag is false, i.e. there are no PCR constraints on any previous key in the hierarchy. The owner evict key can have a PCR constraint on it, but that's the PCR constraint on that key being used, not on that key being loaded. So that's the only potentially surprising piece about owner evict. If you actually want to get rid of a key that has been owner evicted, there is a specific command for removing things from the TPM key storage. It's called flush specific. Normally we don't care, keys leave when they leave, but if for some reason you've set a key to owner evict, and later on you want to set it to non-owner evict, you usually actually want to get rid of it, so it tells you how to do that. So that's really about it for owner evict. It's actually a pretty straightforward command to run. You do have to obviously have the owner authorization or a delegation authorization in order to execute the command, but that's really about it. So that's owner evict in a nutshell. We've now been talking for about an hour after our lunch break. Do we want to take a 5-minute